Hello. All right. So now we're going to look at function composition. So function composition is essentially the idea. So normally when we have a function, we will plug a variable into it. But this is going to be the idea of what happens when we plug a function into another function. So that's what we're going to look at. So let's go over to the board and let's take a peek at one of those. Okay. So we're going to start off with, oh, no, that's not the thing. Okay. So we're going to start off with, so let's say we have f of x. And that is, x plus 2. And let's say that g of x is x minus 3. Okay, so in this case, function composition can be written as f of g. So it would be f of g of x. So let's start by explaining how the heck we're supposed to read this. So this is f of g of x. Okay, so that's a weird statement. So let's start with just talking about g of x. So g of x means that the x value is being plugged into g. So we're reading this right to left. So x gets plugged into g, and then whatever g is gets plugged into f. So if we wanted to write this in a much easier manner, the way we would do so is we would write, so g has x plugged into it, and then f has g plugged into it. So really, we're just plugging stuff in as we go. So in this case, we know that f normally has x plugged into it. So let's go ahead and bring this guy down. So we have f of x is equal to x plus 2. But now we're going to come over and we're going to plug this guy in instead. So we're going to write it as, so it's f of g of x. So when we write that, so we get g of x plus 2. In the future, I'm just going to write it as g's, but for now, it's g of x. So what the heck even is g of x? Well, g of x is just x minus 3. So what we're really doing is we're doing the function with x minus 3 plugged into it. So it's okay. So then we say we got x minus 3 plus 2. Oh, I don't know why I wrote 4. I'm so sorry. I don't know why I wrote that 4 there. That was supposed to be 2. So x minus 3 plus 2. Okay. So if we simplify that a little bit, so that's x minus 3 plus 2. Minus 3 plus 2. That's the same as minus 1. So x minus 1. So we can bring that in as the answer. So f of g of x equals x minus 1, which means the original. So we say equals x minus 1. So all we did was we took this guy and we replaced him with that guy. This is typically how function composition works. Instead of just having, a function with variable plugged in, instead of a single letter, we're replacing that letter with, whatever the other function happens to be. Now, we don't always have to do it this way. There are times where we can make this much simpler, much easier on ourselves. But in general, that's what we're doing. We're taking one function, plugging it into the other. So let's go back to the lecture here for a second. So that's what function composition is. So now let's talk about substitution using numbers. So we're going to be evaluating a composite function with actually some numbers to look at. So let's go over and let's get some different stuff this time. So let's say we have f of, let's say we have a brush. Say f of x is equal to, let's say, x squared plus 1. Let's say g of x is equal to, let's say, 3x minus 5. Okay. And let's say we want to evaluate, so we got f of g, so f of g of 3. Okay, so what this means is that, so we always go right to left. So whenever we're doing function composition, we always go right to left. So what this means is we have the function at, well, actually, I say we start right to left, then start on the left, my bad. So we have 3, and 3 is plugged into g. But g is plugged into f. So this looks complicated and it looks messy. So let's find a better way to write this. So the best way to write this is to just understand what we're doing first. So the first thing we're going to do is we're going to take this 3 and we're going to put it into g. So that'll give us g of 3. Okay, and let's figure out what number that is. Because that number, whatever that number is, we're going to plug that number into f. So let's plug 3 into g. So g of 3 would be 3 times 3 minus 5. So that'd be 9 minus 5. So that's just 4. So we're going to take that 4, and we're going to plug that into f now. So now we're going to have f with g plugged into it. So that's going to be f at 4. So f at 4 is going to be 4 squared plus 1. 4 squared is 16. 16 plus 1 is 17. All right, cool. So that means the answer to this entire thing is just 17. So now we didn't have to go through all that algebra because we know it's with the number plugged in. So we're just going to plug in the numbers. So whenever we're doing function composition, we're just going to plug the number in on the right. So we plug that guy into the one on the left, and then that into the left, and then that into the left. And we just keep going and going and going with as many functions as we have. I'm only going to have you be doing 2, but know that if we wanted to keep going, we could. So now that we know f of g, let's do a different one. Let's do g of f. And I know what you might be thinking. You might be thinking, oh, well, now what do we do now? We just switched all the stuff. Well, first of all, we're not going to use x. I don't know why I put an x on there. That's my bad. I'm sorry. Let's put a 2 in there. So now we're doing f. So we're doing g of f of 2. So g of f of 2. So we're starting off with this 2. And we're going to plug that guy into f. So we got f of 2. So f of 2, so we got 2 squared plus 1. So 2 times 2 is 4. 4 plus 1, that's going to be 5. All right, so now we're going to take that 5. We're going to plug that 5 into g. So now we got g of 5. So it's going to be 3 times 5 minus 5. So 3 times 5 is 15. 15 minus 5 is 10. So our answer is just going to be 10. So that's g of f. So pretty straightforward, So just go start on the right, plug that guy in, and then whatever you get from there, plug that guy in, so on and so forth. Now, there's one more I'm going to throw up here. And conceptually, it is the same as everything we've done so far, but I see this one a lot, and I know that this one has a tendency to freak students out when they see it for the first time. So we are going to do, f of f. So we're doing f of 1. So now you might be looking at this thinking, wait, what the heck does that even mean? Well, it means we're going to take 1 and we're going to plug it into the f function. So you say, okay, so f at 1. So it'd be 1 square plus 1. So 1 square is 1. 1 plus 1 is 2. So then, just like normal, we're going to take this number and plug it back into the original. So again, we're doing the same process here. It just so happens that, we're taking f and plugging it, we're taking what we get from f and plugging it back into f. So now we're doing f of 2. And that's going to give us 2 square plus 1. 2 square, of course, is 4, plus 1 is 5. So the answer to this would be 5. So it is actually pretty nice to do this with numbers because then you just go, oh, plug this in, and then whatever you get, you plug that into the next guy. Pretty straightforward to evaluate a composite function. If they give you numbers, they want numbers, well, you just start at the right, plug it in, and go on about your day. Now, things start getting a little more hectic later on. So I'm going to leave these up here for now so we can reference them later. But we're going to go back to the lecture. So yeah, so start by identifying which function is the internal one. So that's the one on the right. So, you plug the number into the one to the left of it, and then you plug that in again, and then, we just did all of that. You're going to do that with some functions on the independent practice. It's going to be pretty straightforward while you have numbers. But then we're going to do some algebra. So now, let's say that we don't have numbers. So if we have x, we're going to do what we did before, but we're going to be a little smarter about it. We're going to be a little smarter about how we do this. So we go back over here. And so now I'm going to write the question first. So I'm going to write the question before we do anything because that can be a bit messy. So we'll start off, say we have f of g. So now, before we get into all of this algebra, let's look at where we're getting this x plugged into. So this x is getting plugged into g. Okay. So that means that this g is what we call the internal function. So internal means that we're going to be taking this g fella and plugging it into f. So that means f is what we call the outer function. Now, when you know which one's the internal and which one is the outer function, you don't want to put parentheses in your outer function. The reason why is going to become pretty obvious here in a second. So just like before, so we plug x into g. So g of x is 3x minus 5. So okay. So then that means we're going to take this 3x minus 5. We're going to plug that into f. So I'm going to use a green marker for this. So we're going to plug that into f. So now we have f at 3x minus 5. So what that means is wherever we had an x before, we are now going to put a 3x minus 5. So we got 3x minus 5 squared plus 1. So you'll notice here that I just plugged the 3x minus 5 into the parentheses where I used to have an x. That's why we put those parentheses there, so that whenever we go to plug it back in, we can just put, whatever g happens to be into there to solve it for us. So that means our final answer will be 3x minus 5 squared plus 1. Now, we could simplify this a little bit by multiplying out the 3x minus 5 squared. If you want to do that, go ahead. I'm not going to, because there's another example I want to show you, and I don't want to take up too much time with simplifying right now. You might need to simplify on your homework, but I'm going to leave that to you guys because we've already kind of gone over how to do that. So that's f of g, and we could do g of f by doing it the exact opposite way, but instead what I'm going to do right now is I'm going to go over f of f again. So hold on one sec, I need to erase these parentheses because we're not using them right this second. So just go ahead and erase those. Okay, so now what we're going to do is now we are going to do g of g. So we're going to do g of g of x. Okay, so just like before, we're going to be plugging this x into g first. So g of x is 3x minus 5. However, this time when we go to plug it in, we need to be careful and make sure that this is in parentheses. So we know that for g of x, so 3x minus 5, so this x is the one with parentheses. Okay, so we're putting this guy right here, into these parentheses over here. So we're doing g at 3x minus 5. So that means we've got 3 times 3x minus 5 minus 5. So that would be our final answer, is going to be 3 times 3x minus 5 minus 5. So we essentially plugged the equation into itself. That is okay. That is absolutely something we can do. We don't have to worry too much whenever we do that. We could go ahead and multiply the 3 times the other stuff. But again, that's going to be simplifying, and I want to make sure that you guys can see more of these examples rather than just all the simplifying. So this is how it works when you plug a function into itself. You basically just say, oh, okay, so this is the guy that I want. I'm going to plug that in wherever I have an x. So I'm going to grab it, write it out, and then write it in the new guy. And this is why I will write g, and then I will write g with the thing plugged in, so that you know where you're replacing, what you're replacing, and where you're replacing at the same time. This can take a little bit of getting used to. You kind of need to see it a few times before it really starts to click. I would recommend going ahead and making up your own functions and then just practicing, f of g, g of f, and f of f, and g of g. So I'll go ahead and do one more f of f before we move on. So let's erase all that. Okay, now let's grab, let's do f of f real fast. So we've got f of x. So we know that f of x, oh, that arrow was a bit too long. So f of x is so f of x is x squared plus 1. So I'm going to put this in parentheses. I'm going to put parentheses over here on my x squared. So that means when I plug this guy in, I'm going to get f of x squared minus 1, or plus 1, sorry. So that means I got x squared plus 1 squared plus 1. So again, this guy right there is getting replaced with this guy right here. So when I go to plug it in, I know where that replacement goes. This is just a nice way to keep the algebra a little bit simpler, because it's essentially what we did before when we were plugging the numbers in. It's just now, instead of putting a number, we're putting the algebra in. And of course, we can simplify this. I would recommend you go ahead and do this just for a little bit of practice. But other than that, yeah, no, that is just about everything to do with function composition from an algebra perspective. So let's go back and let's see. And that is going to be it for this little stretch. Of course, this is the example that we will be going over together for the synchronous hours. But yeah, other than that, next time, I believe, yeah, so next time is going to be lesson 8. So I will see you guys for that one. You have an awesome day. Bye-bye.